Hey guys, hey my friends. I hope you have been doing great. I hope you have had the best exams this time. You have had the simplest exams this time. And a lot of you have been asking for paper 1 2 Feb March to be solved. This is multiple choice questions. So today I decided to solve these multiple choice questions. So you can check in the video description to get the question paper. So let's start. So this is the question paper which has been done for Feb March. That is India. The paper is supposed to be 1 hour and 15 minutes. I'll try my level best to keep time. The paper is 40 marks. I will go straight to the questions. I will not go through the instructions. I will not go through the formula given because I'm used to them. So question number 1, which row shows a physical quantity and its base unit? So a physical quantity must be measured. It should have a unit. We see all of them have units, but we know there are 7 physical quantities ranging from mass, length, time, temperature, amount of substance. We have luminous intensity. We have current. These are 1, 2, 3, 4, 5, 6, 7. So mass is in kilograms, length is in meters, time is in seconds, temperature is in Kelvin. Amount of substance is measured in a unit called the candela. So the amount of substance is measured in the mole, luminous intensity is in the candela, and then the current is in the ampere. So we just check current is in amperes, which shows physical quantity and its base unit. Remember, something is physical because it can be measured by a certain instrument. So all these ones, force is derived, mass is physical but is not measured in grams, it is in kilograms. Temperature is physical, but its SI unit is Kelvin. So the answer is going to be A. A car of mass 850 kilograms is traveling in a horizontal straight line. The diagram shows the two forces acting on the car in opposite directions. One force has 1,200 newtons and the other force has 1,600 newtons. What is the magnitude of the acceleration of the car? So if we know that force, resultant force is mass times acceleration. So the resultant force is 1,600 minus 1,200. Of course, the resultant force is in the opposite direction, so the acceleration is going to be negative, but we're just interested in the magnitude. So the acceleration is going to be 400 divided by the mass, which is 850. So 400 divided by 850, that is 0.47. So this is 0.47 meters per second squared, which makes the answer to be A. An object of mass m is suspended by a spring from a fixed point. The spring has a spring constant k. The object is set into vertical oscillations of period t. Which equation for t is homogeneous with respect to the base units? So we just check the base units. T is period. The base units of t are going to be seconds. K is the spring constant, and we know that K is equal to the force over extension. So it means the units for K are going to be for force, which is kilogram meters per second square divided by extension, which is meters. So it means the units for K are kilogram per second square. Those are the units for K. So T is A is telling us it is, of course, 2 pi has no unit, so I'll just say A is saying kilogram per second square divided by kilogram. So kilogram cancels. So A is giving us per second squared, which makes A to be wrong because on the left-hand side, T is in seconds. We can check B. B is saying meters over K. So, M over K, where M is in kilograms. M is mass, which is in kilograms, divided by K, which is kilograms per second squared. So this is 1 over s power minus 2, which is s power 2. So B is also wrong because on the left-hand side we have only seconds. We can check C. C is the square root of K, which is kilogram per second squared divided by kilogram. So this gives us s power minus 1. So it is still not correct. So C is wrong. So our answer is automatically D. We can check D. D is telling us that it is the square root of course I ignore 2 pi, square root of m, which is kilogram, divide by k, which is kilogram s power minus 2, which is going to be the square root of s power 2, because kilograms cancel, so I remain with 1 over s power minus 2, which is the same as, of course, 1 over s power minus 2 is the same as s power 2, which is s. So it means D is giving us the units on the right-hand side as those on the left-hand side, so the answer is going to be D. An object of fixed mass is initially at rest. That means initial velocity is 0. The object then moves away from point P with a uniform acceleration. So acceleration is constant. So if the acceleration is constant, also means the resultant force is going to be equal to a constant, because remember the resultant force is equal to the mass times the acceleration. The acceleration is constant, the resultant force is constant. Which statement describes the resultant force acting on the object when it is moving? Remember, resultant force is directly proportional to the acceleration. If the acceleration is constant, the resultant force must be constant. Remember, the object is moving, so it means the resultant force cannot be, the object is moving. So the resultant force, first of all, cannot be 0, because if F equals to 0, it would mean A is equal to 0, because they are directly proportional. So D is automatically wrong, because D is saying the resultant force is 0. It increases uniformly with respect to t. A is also wrong, because we said resultant force is directly proportional to acceleration, and since the acceleration is uniform or constant, the resultant force must be constant. It is constant but not 0, so the answer is going to be B. It is proportional to the displacement from point P. Of course, the resultant force is not is dependent on the acceleration, it's directly proportional to the acceleration, so C is automatically wrong. A projectile is launched at an angle of 25 degrees to the horizontal with a horizontal component of a velocity 13 meters per second. So I'll just sketch a simple projectile here. It has been launched at an angle of 25 degrees to the horizontal. So V in the horizontal, I'll quote Vx, is given as 13. And of course, if V is the resultant velocity with which it is launched, so it means 13 is the same as V cos of 25. That is if we resolve in the horizontal. Then velocity in the vertical, I'll quote Vy, is going to be automatically V sine of 25. So what is the vertical component of the velocity? So I'll divide the two equations. I have this equation and this one here. So I'll say V in the vertical over V in the horizontal, which is 13, is equal to V sine of 25 divided by V cos of 25. So small v has cancelled out. So it means velocity in the vertical is going to be 13 sine 25 divided by cos 25 is tan of 25. So I'll just say 13 tan of 25, and it is giving me a 6.1. So this is going to be 6.1. So the answer is going to be B. The ball is released from rest at position X. So initial velocity is 0. The graph is starting from 0. At t equals to 1, it bounces inelastically. It is inelastic. So that means there is loss of some energy from a horizontal surface and rebounds, reaching the top of its bounce at 1.5 seconds. What is the total displacement of the ball from its original position? So this part here, it shows when it is just falling downwards before it bounces. At this point, it bounces. So let me say distance down. Distance when it is going down, of course, distance is going to be equal to the area. Distance is equal to the area under the graph, and it is a triangle, so I'll say a half times the base, which is 1.0, times the height, which is 10, and this gives me I think this is 5 meters. That is distance downwards. Then distance up, when it rebounds, of course, it moves upwards. So that's why you see the velocity is decreasing up to 0. So I'll say distance up. Of course, it is also equal to the area, which is a half, times, so this is the area I'm looking for. It is a triangle. I can say the base is 1.5 minus 1, which is 0.5. Then the height is this one here, which is 5. So that is times 5. And I think this gives me 1.0.5 times 5 times 0.5. That's 1.25. So this is distance up. This was distance down. So the question is, what is the total displacement of the ball from its original position? So displacement is a vector quantity. So I can say the initial distance downwards is positive, plus distance upwards will be negative. So negative 1.25. So in other words, I have 5 minus 1.25. 5 minus the answer, that is 3.75 meters, which makes the answer to be B. What is the definition of acceleration? Of course, we know that acceleration is final velocity minus initial velocity over t, which is the same as the rate of change of velocity. So number 7 is automatically, the answer is A, the change in velocity per unit time, the rate of change of velocity. Now you can't say rate of change of velocity per unit time. This one is a repetition. Imagine saying v minus u over t, that is rate of change of velocity again per unit time. So this becomes v minus u, because rate of change of velocity is this one alone. When I say per unit time, again I'm dividing by t, so it becomes v minus u. So this becomes wrong. Then rate of change of speed, of course, acceleration is a vector. So we consider velocity. Resultant force per unit mass, that's not the definition of acceleration. Two balls P and Q of equal mass, so the mass is the same, move along a straight line directed towards each other as shown. Ball P has velocity 1.3 to the right. Ball Q has velocity 0.5 to the left. So I'll say velocity to the right positive and to the left will be negative. P and Q collide with one another. The collision is perfectly elastic. That is a very good point. When they say perfectly elastic, it means the relative speed of approach must be equal to the relative speed of separation. So let's first find the relative speed of approach here. The word relative means we subtract the speeds. So speeds to the right hand side positive. So I have 1.30 minus, that is the word relative. But speeds to the left hand side is negative. So I'll say minus, that is for relative, then negative because it's in the opposite direction. So minus negative 0.50. And I think this gives me 1.80 meters per second. That is the relative speed of approach. So it means if the collision is perfectly elastic, the relative speed of approach should be equal to the relative speed of separation. So just check which combination gives us 1.8. Remember, velocity is to the right positive, to the left negative. So this is positive, positive, negative, positive, 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 negative, positive. But since we started with the velocity to the right, then velocity to the left, we should always maintain that order. For example, here they are both to A, sorry about this. For A, they are both to the right. So I will say 0.22 minus 0.58. So I didn't put a negative because they are both to the same side. So that is, this one is giving us negative 0.36. Even the magnitude is not the same. We can check the second one, 0.4 minus, of course, this one gives us 0. Then we C, so it means A is wrong, B is wrong. We can check C. C is telling us that we have 0.99, sorry, 0.99 minus 0.19. So this is giving us 0.8 as the relative speed of separation. So this is also wrong. So the answer is going to be automatically D because we have speed to the right. That is the relative speed of separation is 1.30 minus negative 0.5, which we already saw as 1.80 meters per second. So it means the answer is D. A basketball player hits a ball vertically downwards with a speed of 2.4 meters per second from a height of 0.9 meters. Air resistance is negligible, which means equations of motion can apply. What is the speed of the ball as it hits the ground? So since equations of motion can apply, I'll look for the easiest equation such as v squared equals to u squared plus 2as. So want v. So v is going to be the square root of initial velocity is 2.4 squared plus, because it's falling vertically downwards, I'll maintain the positive here because g is a positive. So this will be 2 times a, which will be 9.81 because we are considering gravity here. Then times the distance that has fallen is 0.90. So I have 2.4 squared plus open brackets 2 times 9.81 times 0.9. Then I find the square root of the answer. So I'm getting the answer as 4.84. So V is 4.84 meters per second. So the answer is going to be B. Alternatively, because it's falling, it is losing kinetic energy, it is losing gravitational potential energy as it gains kinetic energy. So I will say the gain in kinetic energy is going to be equal to the loss in potential energy. This equation can only be used if air resistance is negligible. So the gain in kinetic energy is going to be a half times mass times the initial or times the final speed which we want, v squared, minus the initial speed which we had, which is 2.4 squared. So that is what we have as the gain in kinetic energy. I'm using a half mv squared. So this is going to be equal to the loss in potential energy, which is m, then times g times h. Of course, m cancels out. So I have that v squared is going to be equal to 2. I'm taking the 2 to the right hand side, times g, which is 9.81, times h, which is 0.90. Then I'll say plus. I'll take this one the other side, minus 2.4 squared to the other side. So it becomes plus 2.4 squared. You notice that this equation, this is almost the same as this. I just find the square root both sides. So V is going to be the square root of this 2 times 9.81 times 0.90 plus 2.4 squared, which gives us exactly the same answer. A ball falls through a liquid at a constant speed. Constant speed. It is acted upon by 3 forces: an upthrust, drag force, and its weight. The liquid has uniform density. Which statement is correct? Let's say this is the liquid and the ball is in here and is surrounded by the liquid. If the ball is surrounded by the liquid, it means the difference in the pressure between the top and the bottom of the ball remains constant. And remember, the upthrust depends on that difference. So it means if the ball is fully submerged, then the upthrust force is constant because it depends on the difference in the pressure between the top and the bottom. If it is fully submerged, the difference in pressure between the top and the bottom will remain the same because it also depends on how much of the object is submerged. It is the same size of the object which has been submerged, the same weight of the object which is fully submerged. So the upthrust for a fully submerged object remains constant because it's just the difference between the top of the object and the bottom of the object. And remember, the difference in the pressure is due to the depth, and the depth is going to be this height here, which is going to be constant. So, and how about the drag? Because the speed is constant, the drag force also is constant because the drag depends on the speed, or resistance depends on the speed. In fact, the drag could be directly proportional to the square of the speed. So if the speed is constant, the drag is going to be constant. So let's see what is given here. The drag force increases? No. The drag is constant if the speed is constant. The drag force is equal to the sum of the up thrust and the weight. Of course, the up thrust acts upwards. A ball falls through, it is falling, so it is going, motion is downwards. So up thrust is up, the drag force is also up, drag is also up, and the weight is down. So it means this statement is wrong. Up thrust plus the drag is equal to the weight. So up thrust is constant with increasing depth. So it means our answer is going to be C. The weight is greater than the sum of the drag force and the up thrust. It is moving with a constant speed, which means the acceleration is equal to 0. That means the weight should be equal to the up thrust plus the drag force, so that the acceleration is 0, and that means the resultant force is 0, so the speed becomes constant. So it means the last statement is not correct. So the answer is D, is C. Some small solid cubes each have mass 1 kilogram and size 5 centimeters. These small cubes are stacked together to form a large solid cube with sides of length 2 meters. What is the weight of the large cube? So this is going to be very simple. We just need to find the number of cubes. So the volume of the large cube is going to be 2 by 2 by 2, which is equal to 8 meters cubed. Then the volume of the small cube is going to be 5 divided by 10 by 100 is 0.05. So the volume is going to be 0.05 times 0.05 times 0.05, which is 0.05 times 0.05 times 0.05. So this is 1.25 times 10 to the power of negative 4. This is meters cubed. So it means the number of cubes is just, we are just going to divide these two. So it will be 8 divided by 1.25 times 10 to the power of minus 4. This is meters cubed, this is meters cubed. So I'm finding the number of cubes. So I'll say 8 divided by the answer, which is 64,000. So we have 64,000 cubes. So remember, each cube has a mass of 1 kilogram and we want the weight. So the weight is equal to m times g, which is going to be the number of cubes, which is 64,000, times the mass of 1 cube, which is 1.0, then times g, which is 9.81. So I'll just multiply this by 1 times 9.81. So this is giving me 627,840 newtons. So this is approximate. So it means this is wrong, this is wrong. So you have to choose between these two. So this is approximately 63. Then this will be 0, 0, 0, 4 zeros, 1, 2, 3, 4 newtons. So we have giganewtons and meganewtons. Let's check meganewtons. That is 0.63. Removing mega, I'll say exponent 6. That is 630,000. So the answer is going to be C. This one is going to be wrong because if I check this, sorry about that. This is going to be wrong because if I check it, it will be 0.63 giga is exponent 9, which is a very different value. So that makes the answer to be C. Question 12. A borehole of depth 200 meters contains both oil and water as shown. The pressure due to the liquids at the bottom of the borehole is 17.5 megapascals. The density of the oil is 830. The density of water is 1000. What is the depth x of the oil? So I'll first find this height here, which is going to be 2000 minus x. So the pressure of the oil here is going to be the density H of the oil. Of course, pressure due to a liquid is equal to H density times G. So total pressure total is going to be pressure due to the oil plus pressure due to the water. So pressure due to the oil will be the depth, which is X, times the density of oil, which is, I've just said dot, 830, times G, which is 9.81, plus pressure due to the water, which is the depth, the depth is 2000 minus X, the density, which is 1000, then times G, which is 9.81, and this should be equal to total pressure, which is 17.5 times 10 to the power of 6, because it is megapascals. Okay, so I'm trying to simplify this. So I have, I'll begin by dividing both sides by 9.81. So I have 830x 830x, then minus 1000x is equal to 17.5 times 10 to the power of 6 divided by 9.81, then minus. So I first took 9.81 to the right hand side by division, dividing both sides. Then I open the bracket where I have minus 1000x, and I have 2000 times 1000. When it crosses to the right hand side, it becomes minus 2 times 10 to the power of 6. That is 2 millions. So this means, I think this is negative 170x equals to, so I have 17.5 exponent 6 divided by 9.81, then minus 2 exponent 6. So I have negative 216,106, negative 216,106, 216,106.0148. So I'll divide both sides. Divide both sides by negative 170. So I get x as 1271. So x is 1271 meters, or approximately 1270 meters. So which means our answer is going to be D. A rod is pivoted at one end. Initially, the angle theta of the rod to the horizontal is 0. The weight of the rod causes a moment m about the pivot. The rod is then rotated in the vertical plane so that the angle theta of the rod increases from 0 to 180 degrees. Which graph shows the variation of m with theta? Okay, I'll just try to sketch a diagram here for us to understand this. So let this be the pivot, and we are going to put this as the rod. Let it be pivoted here. I'll erase this part here because it's pivoted at one end. Of course, its weight acts at the center, and its weight is W. Let's say the distance between the center and the pivot is D. So of course the weight is causing a clockwise moment. So I'll say M. I'll start by saying M is equal to, that is the moment, is equal to the weight times the perpendicular distance D. And this is the same as M equals W times D cos of 0, because cos of 0 is 1. So this is the same as W. So in general, M is equal to W times D cos theta. In general, M is equal to W times D cos theta. What do I mean by that? Let me change the color and I draw a different position for the rod. Now, if it is moved in the vertically, so that now the angle is increasing. Now that space is not enough. I have to sketch here. Let me sketch here. Let's say it is now moved in the vertical so that the angle has increased from 0. This was the initial position where the angle was 0. Now the angle has become theta. And remember, the weight acts vertically downwards. So D was this distance here. So this is theta. The perpendicular distance is this distance here. This is the perpendicular distance and it is under adjacent. Adjacent hypotenuse, that is cos. So if I want this perpendicular distance, call it x, I'll say cos of theta is equal to adjacent over hypotenuse, which is d. So it means the perpendicular distance would be d cos of theta, which means the new moment, let me call it m2, is going to be the weight w times perpendicular distance, which is d cos theta. So it means the moment, in general, moment is going to be that weight times d cos theta, where theta is the angle measured from the horizontal. So let's check. If theta equals to 0, we know that m equals to a maximum value, which is w times d. Then we can also check if theta equals to 90 degrees. Of course, we know that cos of 90, m is going to be wd cos of 90, which gives us 0. We can check, because it's moved up to 180, so we can check if theta equals to 180 degrees. So m is going to be wd cos of 180. Of course, cos 180 is -1, so this is going to be negative wd, which means our graph crosses the x-axis. So A is wrong, B is wrong. Now we have to choose between C and D. Of course, this is not a straight line. This is a cosine curve. So C is automatically wrong. And therefore, the answer is going to be D. So this is, because this is a cosine curve, M is directly proportional to cos of the angle. So it means the answer is going to be D. A hinged trapdoor is held closed in the horizontal position by a cable. Three forces act on the trapdoor: the weight W of the door, the tension T in the cable, and the force H at the hinge. Which list gives the three forces in increasing order of magnitudes? Okay, so first of all, let's resolve these forces. There is a vertical component of this H. I will just say H in the vertical, called HV. It points downwards. Then, of course, it has a horizontal component which has no effect. I'll call this H, HH. Now let me call this one HY in the vertical, then I'll call this one HX. Then we have T has a component in the vertical, which is going to be T. I'll call it T in the vertical, TY. It also has a component in the horizontal, I'll call it T in the X. So which equations relate these to? For equilibrium, because it's horizontal, T in the vertical, of course, there is no any other force acting upwards, should be equal to H in the vertical downwards plus W. The component of H downwards plus the component, W plus the component of H downwards. They will give us the component of T upwards. That's number one, which means W alone is going to be equal to T in the vertical minus the component of H in the vertical. Number two, if we took moments about the pivot or about the hinge, if we took moments about the hinge, W causes a clockwise moment and the component of T will cause an anti-clockwise moment. Let's look at the distances. Let me call this one distance. I'll call this one distance X. No, I'll call it D1. And I'll call the distance of W from the pivot, I'll call this one D2. So taking moments about the hinge, W times its perpendicular distance, which is D2, that is clockwise, is equal to the vertical component of tension, which is Ty, times its perpendicular distance D1. But remember, when you look at the diagram, you notice that D2 is greater than D1. If D2 is greater than D1, the only way the products will be equal is when W is less than Ty. So W must be less than Ty. So W is less than the vertical component. Remember, of course, a component of a force is less than the resultant force itself, because we resolve the force in the vertical and the horizontal, which reduces its value. So the weight is less than the vertical component of T, because if distance D2 is greater than D1, the only way the products can be equal is when W is smaller and Ty is bigger. So it means W is less than Ty. That's number one. Number two, remember W is equal to Ty minus Hy. W is less than Ty, which also means, and of course, Ty is less than T. So it means automatically W is less than T. W is smaller than T. Let's check. W should be smaller than T. Because it is in increasing order, W should come before T. So A is wrong, B is wrong. So we have to choose between C and D. Because in C and D, W is coming before. W is coming before T. But then remember, W is T minus Hy. W is T minus Hy. So Ty is Hy plus W, or W is T minus Hy. We've already seen that W is less than Ty. To get Ty, or if I try to make H the subject, I will say H equals Ty minus W. So if H in the vertical is equal to Ty minus W. Remember, W is already less than Ty. So it means W is going to be less than Hy. So that means the answer here is going to be automatically C. So W is the smallest, followed by H, then the largest is going to be T. What is the definition of force? Of course, force is equal to the rate of change of momentum. So force is the rate of change of momentum. The answer is going to be C. Now, we always make a mistake of saying force is mass times acceleration. Force is defined as the rate of change of momentum. A boat moves at a constant velocity v through still water. Constant velocity, which means acceleration is 0. Constant velocity, which means acceleration is 0. A constant drag force F acts on the boat. What is the power used by the boat to move through the water? Of course, we know power is equal to work done over time taken, which is force, times distance or displacement, divided by time, which is the same as force times velocity. So the answer is automatically B. Work done over time, force times displacement over time, and displacement over time is velocity, so the answer is force times velocity. The diagram shows 4 forces acting on a circular disk. Each force has a magnitude F. 2 of the forces act vertically and the other 2 forces act horizontal. All forces act in the same plane as the disk. No other forces act on the disk. The disk has diameter d. So this diameter is d, the distance is d. Which statement is correct? First of all, the disk is in equilibrium. Let's check if the disk is in equilibrium. So resultant force, F resultant, in the vertical it is 0, in the horizontal it is 0. Resultant force is 0. Then let's check resultant moment. So these two in the vertical, this causes a clockwise moment, so they cause a clockwise torque. So torque T1 in the vertical caused by the vertical forces is going to be one of the forces times the perpendicular distance, which is d. Then these two also cause another clockwise moment. So it means total torque will be plus. The torque by these ones will also be F times perpendicular distance between them, which is d. So the total moment or total torque is going to be twice F times d. So the question is, which statement is correct? So not in equilibrium. So A and C are going to be wrong because they are saying it is in equilibrium, yet it is not in equilibrium. So not in equilibrium, not in equilibrium, but then the resultant moment is twice 4D. There is no resultant force. So C is wrong because saying resultant force is 4F. It is not true. The resultant torque is twice FD. So the answer is going to be D. We have seen that the total moment is going to be 2FD. A ball is projected into the air from a horizontal ground and follows the path shown in the diagram. At points Q, R, S, and T, the ball has kinetic energies EQ, ER, ES, ET, respectively. The heights above the ground of these 4 points are shown. Air resistance is negligible. If air resistance is negligible, equations of motion can apply. Also, because it's moving against gravity, it is losing kinetic energy as it gains potential energy. That means the loss in kinetic energy is the same as the gain in potential energy at any point. At any point, the loss in kinetic energy is the same as the gain in potential energy. So what is the difference in kinetic energies of the smallest? Which difference in kinetic energies is the smallest? So the first one is saying EQ minus ES. So it means ES, let's say EQ. EQ minus ES is just going to be the gain in potential energy, which is mg times change in H. So this is going to be equal to, I will start with the highest, which is S. Oh, I can even start with this one. Of course, it is just going to be a negative. There is no problem about that. So this is going to be mg. H is, the difference in H is 1.5 minus 1.6. So this is just going to be negative mg times 0.1. Okay, let's check this. So this is negative mg times 0. Of course, the negative just means the potential energy at S, or the loss in kinetic energy at Q. The loss in kinetic energy at Q is smaller than the loss in kinetic energy at S. Then let's check this one. I will just subtract the differences in the heights, S and R. So this will be, I'll just say mg into S and R 1.8 times minus 1.6. So that is 0.2. Then C, we have T and Q. This is going to be mg into T is 1.3 and Q is 1.5. So the difference is 0.2. Then T and R. T is, so this is mg into T is 1.3 and R is 1.8. So I can say 1.3 minus 1.8, or the other way around. The order doesn't matter. We just want the magnitude. So this difference is 0.5. So we want the smallest difference. So the answer is going to be A. Which difference in the kinetic energies is the smallest? So the answer is this one, because you notice that the difference in H is 0.1. The battery. Now, some people will complain, teacher used mgh for potential energy. I just made a statement, loss in kinetic energy is gain in potential energy, or the other way around, because air resistance is negligible. Very simple. The battery of a small tablet computer is initially uncharged. It is connected to a constant 10-watt power supply for 2 hours. To charge the battery, the efficiency of the charging process is 80%. What is the total energy stored in the battery? So we know that efficiency is equal to power output divided by power input. So let's first find the power output, which is going to be the efficiency. This is 0.8 equals to power output divided by 10. So this is going to be 0.8 times 10, which is 8 watts. So that is the power output. And we also know that energy output is going to be power times time. So this is going to be 8 times T, which is 2 hours, times 3,600 to change it to seconds. So we have 8 times 2 times 3,600, which gives us 57600 joules. So the answer is going to be, I think it is C. 1, 2, 3, 4. So that is 5.8 times 10 to the power of 4 joules. So the answer is C. An initially stationary firework explodes and splits into two fragments that move horizontally in opposite directions. This one is very important. So if I consider conservation of momentum, total momentum before exploding is 0 because it is initially stationary. Then when it explodes, one moves to the other side, one moves to the other side. Now the masses, the total kinetic energy transferred to the fragments by the explosion is E. The one fragment has mass m and the other has mass 2m. So I'll start with conservation of momentum. So let's say momentum of this one is to the right, momentum of this one is to the left. So this will be m. Let its speed be v1 plus negative because in opposite directions. I'm finding total momentum after. So the mass is twice m, let its velocity be v2. So this is equation number 1. Alternatively, you can simplify this and you notice that v1 is equal to twice v2 when you simplify this, or you can simplify this and say v2 is equal to v1 divided by 2. Consider that first. Total kinetic energy transfer to the fragments by the explosion is E. How do we find total kinetic energy? For m to be a half m v1 squared plus for 2m it will be a half 2m v2 squared. This should be equal to E. Okay, so we are having I'm going to substitute for v2 in this equation here. So I'll say, of course, this one has cancelled out. So I have that a half m v1 squared plus m, where there is v2, I'm going to put there v1 over 2, but this is squared. This should be equal to m to E. So when I simplify this, I have a half m v1 squared plus m v1 squared. When I square the denominator, I have 4. This is equal to E. Okay, so when I add these two, a half plus a quarter, I think that is 3/4. That is a half plus a quarter, that is 3/4. So I have 3 over 4 m v1 squared equals to E. I'm trying to make v1 the subject, so v1 is going to be 4 times E. I divide this by 3m under square root, which means my answer to question number 20 is going to be D. A spring is fixed at one end and extended by applying force F to the other end. The spring has extension X and elastic potential energy EP. The spring constant is K. The spring obeys Hooke's law. If it obeys Hooke's law, it means F is equal to K times X. Which relationship is correct for the spring? So F is equal to Kx. Remember, elastic potential energy is equal to a half F times X, which is a half, where there is F, I'm putting Kx, then again times X. So it becomes a half Kx squared. In other words, elastic potential is equal to a half Kx squared, which means elastic potential is directly proportional to x squared, which means our answer is going to be D. A force extension graph is produced for a metal wire. What must describe the limit of proportionality of the wire? Remember, the limit of proportionality is where the line stops being straight. Where the line stops being straight, that's where Hooke's law stops being obeyed. So the point beyond which Hooke's law is not obeyed, of course, that is going to be the limit of proportionality, because if force is no longer directly proportional to x, then Hooke's law is no longer obeyed. So that is a point beyond which Hooke's law is not obeyed. So that is automatically B. A point at which the wire breaks, that is not the limit of proportionality. By the time it reaches to breaking point, it has also undergone plastic deformation. The point beyond which the wire cannot return to its original length, it has already reached plastic deformation. The point beyond which the wire starts to deform plastically, that is the elastic limit. A spring has spring constant of 6 Newton per centimeter. It is joined to another spring whose spring constant is 4 newtons per centimeter. A load of 80 newtons is suspended from the composite spring. Okay, what is the extension of the composite spring? Okay, this is very simple. If you're a very good student, okay, I will start with a layman. Because the same weight is experienced by each spring, I can find the extension here, which will be, I'll quote E1, using K is equal to F over X, or F is equal to KX, or X equals to F over K. So for this one, the force is 80 divided by K, which is 6. So this is 80 divided by 6. So this is 13 centimeters. Then I will check this one, E2. It will be 80 divided by 4, which is 20 centimeters. Because they're in series, total extension is going to be the sum, which is 13 plus 20, which is 33 centimeters, which makes the answer to be D. But a good student must have noticed that for springs in series, we treat them the way we treat resistors in parallel. That is, 1 over total constant is equal to 1 over 6 plus 1 over 4. So which means total constant is the product over the sum, 6 times 4 over 6 plus 4, which is 24 divided by 10, which is 2.4. So it means total constant is going to be 2.4 newtons per centimeter. That's total constant. So that means if I want the total extension, E total is going to be the load, which is 80 newtons divided by total constant, which is 2.4. So I can check. 80 divided by 2.4, that is 33. It is also 33 centimeters, so it means the answer is still D. The range of frequencies of sound waves emitted by blue whales is 10 Hz to 40 Hz. The speed of sound in seawater is approximately 1.5 kilometers per second. I think this is 1,500 meters per second. What is the approximate wavelength of the sound waves emitted by blue whales? So let's check. Wavelength is equal to speed over frequency. For 10 Hz, this will be 1,500 divided by 10, which is 150 meters, and we have 1,500 divided by 40, which is 1,500 divided by 40, which is 37.5, which is approximately 38 meters. So the range is 38 meters to 150 meters. So the answer is automatically D. A sound wave is detected by a microphone and displayed on the screen of a cathode ray oscilloscope. The frequency of the wave is 2.5 kilohertz. So this is 2.5 times 10 to the power of 3 hertz. What is the setting of the time base? So let's say the time base setting is X. Remember, the period is equal to 1 over frequency in seconds, remember? And this is the same as the length representing 1 cycle times the time base setting. So the frequency is 1 over 2.5 times 10 to the power of 3. Remember, this is in seconds. Should be equal. The length representing 1 cycle, this is 1, 2, 3, 4. Those are 4 centimeters. So this is 4 centimeters times the time base setting X. So X is going to be 1 divided by, this is in seconds, divided by 2.5 times 10 to the power of 3, then times 4 centimeters. So our answer is going to be in seconds per centimeter here. So let's see, 1 divided by 2.5 times 4 exponent 3. So this is 1 times 10 to the power of minus 4 seconds per centimeter. So seconds per centimeter is 1 times 10 to the power of 4. So this is wrong, this is wrong. So it is 1 times 10 to the power of 4. This is wrong. So it means our answer is A. We can check. Divide this. 1 times 10 to the power of minus 4. Divide, of course, to bring a prefix, you divide by its value. So I'll divide by the value of milli, which is 10 to the power of minus 3. And if I divide this by 1 exponent minus 3, I get 0.1. So this is 0.1 milliseconds per centimeter, not meters cubed, per centimeter. So the answer is A. A source of sound waves with constant frequency moves towards a stationary observer. The observer compares the sound waves arriving at the observer's position with the waves emitted by the source. Okay, let's say by the source frequency is S, by the observer frequency is F naught. What is detected by the observer? Because it is towards. We know that for towards, when an ambulance approaches you, the frequency detected is higher. So the observed frequency increases. What is detected by the observer? A decreased frequency. No, the observed frequency increases. No change in frequency. An ambulance approaching you, the frequency is higher. A decreased wavelength. Let's check. We know that frequency is equal to V over lambda, which means frequency is inversely proportional to wavelength. Because the frequency observed increases, it means the wavelength observed decreases. So the answer is going to be C. A decreased wavelength of the sound waves. No change in wavelength because the frequency has changed, the speed is constant, then it means the wavelength must have changed. So the answer is going to be C. Which type of waves cannot be polarized? Remember, it is only transverse waves which can be polarized. Radio waves are transverse, they can be polarized. Sound waves are longitudinal, these ones cannot be polarized. So the answer is B. UV can be polarized because that is light. X-rays are electromagnetic. Radio waves, ultraviolet, X-rays, those are electromagnetic waves which can be polarized. So it means it is only sound waves which are longitudinal, they are not transverse, they cannot be polarized. A beam of light with a power P has an area A. The amplitude of light waves in the beam is X. The beam of light is then changed to 1 with the same frequency, so it's same frequency, so I'll use the same constant, but with an increased amplitude of 4x. What is the power of the new beam? Okay, so in general, we know that power is equal to intensity times the area. And we also know that intensity is equal to or is directly proportional to amplitude squared. Amplitude but squared. Intensity is going to be amplitude squared. So for the first one, let's say the power P is going to be the intensity. Let's say it is I1 times the area, which is A. But I1 is going to be equal to a constant times the amplitude, which is x. So it is a constant times x squared. So it means P is equal to k x squared times A. That is one equation. Then for the second one, the power, I will call it power 2, is going to be the new intensity, which I'm going to call it A2 times the new area, which is A over 3. But the new intensity I2 is going to be equal to a constant k times the amplitude, which is 4x. So this is 4x but squared. So it means the power P2 is going to be K. Where there is 4x, I'll put times 16 x squared, then times a over 3. So this is the second equation. Now I'm going to divide the two equations. I'll say P2 divided by P is equal to K times 16x squared times a over 3 divided by K x squared times a. So K cancels, a cancels, x squared cancels, x squared cancels, so I remain with the 16 divided by 3. Yes, 16 divided by 3. Let's check. 16 divided by 3, that's 5.3 recurring. So the answer is going to be, so it means P2 is going to be 5.3 times P. I take this P to the right hand side. So the answer is B. Two loudspeakers are connected to the same signal generator. The signal generator produces a single frequency. The loudspeakers face each other so that a stationary sound wave is set up in the region between the loudspeakers. A microphone is connected to the cathode ray oscilloscope and positioned between the two loudspeakers. The microphone is moved along a line joining the two loudspeakers. The signal on the CRO shows 5 maximum amplitudes. So we have 1, 2, 3, 4, 5 maximum amplitudes. The microphone moves a distance of 2 meters from the position that gives the first, that is from here, to the position that gives the fifth, that's up to here. So this distance is 2 meters. So this is 1, 2, 3, 4. Remember, the distance between an antinode and another antinode is always half wavelength. So the distance between a maximum and the next maximum is half wavelength. So the distance between one maximum and another maximum is going to be 2 divided by 1, 2, 3, 4. 2 meters divided by 4, which is 0.5 meters. So what is the wavelength of the sound wave? So I will say 0.5 equals to a half wavelength. So wavelength is 0.5 times 2, which is equal to 1.0 meters. So the wavelength is going to be 1 meter. Two wave sources emit coherent waves. Of course, coherent waves are those coherent. If the sources emit coherent waves, it means they maintain a constant phase difference between them. What condition must be correct for the coherent waves? The waves are emitted in phase. The waves are emitted and move in opposite directions. The waves are emitted with a constant phase difference. So the answer is C. Coherent waves maintain a constant phase difference. A student sets up an experiment to investigate double slit interference. The student uses light of a single wavelength from a laser to illuminate a double slit so that a pattern of interference fringes is observed on the screen. The student finds that the fringes are very close. What could the student decrease in order to increase the separation of the fringes? Okay, from a double slit, we know that the wavelength equals to AX over lambda. Since they have used, over D, now they have used different letters. They have used wavelength, let me see. They have not mentioned wavelength here, so I will just say wavelength lambda equals to slit separation A. They have used R for A. Then they have not mentioned X, so I maintain X. Then where there is D, distance between the slits and the screen, they have put Q. So what could the student decrease in order to increase the slit separation? So X increases if wavelength increases because they are directly proportional. That's number one. X also increases if D increases because they are directly proportional. That's number two. X only increases if A decreases because X is inversely proportional to A. If we want X to increase, then we should decrease A. So it's A which can be decreased. I'm using A instead of R. Let me write R here because A is the slit separation or R is the slit separation. So if we want X to increase, then we must reduce R because they're inversely proportional. So question number 31, our answer is going to be C. What are the definitions of PD and EMF in terms of energy? Of course, we know that V is energy per unit charge. We also know that EMF is also energy per unit charge, or energy is work done, of course. But remember, for PD, it is from electrical to other forms, and for EMF, it is from chemical energy to electrical. So here, 32, the answer is automatically going to be A. W over Q, W over Q. This is wrong. This is wrong. This is wrong. PD is energy transferred from electrical to thermal or to other forms per unit charge, and EMF is energy transferred from chemical to other forms per unit charge. So that is W over Q. So the answer is A. The diagram shows a network consisting of three resistors. What is the combined resistance of the network between terminal X and terminal Y? So these ones are in parallel, but the resultant is in series with 2.2. So for resistors in parallel, total resistance is product over the sum if there are only two. So I'll simply say 1.2 times 4.7 divided by 1.2 plus 4.7. This only works if there are only two. So 1.2 times 4.7 divided by 1.2 plus 4.7. So then I'll add this to 2.2. So total resistance is equal to 2.2 plus the resistance in parallel. So I'll just say plus 2.2. So this is giving me 3.2. So this is 3.2 kilo ohms. So the answer is going to be C. A resistor dissipates 25 watts of power when there is a PD of 4 volts across it. What is the resistance of the resistor? So we know that power in terms of V and R, power is equal to V squared divided by R. So it means R is going to be V squared divided by the power, which is going to be 4 squared divided by 25. So I'll say 4 squared divided by 25, which is 0.64. So the answer is going to be B. The diagram shows a cell with internal resistance connected in parallel with a fixed resistor and a variable resistor. The resistance of a variable resistor is decreased. The resistance of a variable resistor is decreased. What happens to the potential? What happens to the potential difference across the variable resistor and the current I in the variable resistor? So here they gave us V decreases, I decreases. V decreases, I increases. Then we have V increases and I decreases. V increases and I increases. So the easiest way to think about this is let's start with total resistance. Let's fix this to be R, small r, and this one is going to be the variable resistor which is going to be changing. So if we reduce this one, let me call this one RV. So if RV is decreased, it means total resistance or the resistance in parallel becomes smaller. When you have total resistors in parallel and one becomes smaller, total resistance in parallel becomes smaller, which also means total resistance in the whole circuit, because the parallel combination is small. When added to small r, total resistance decreases. So total resistance decreases. If the total resistance in the circuit decreases, it means total current in the battery. Total current in the battery decreases. So total current, it increases because total resistance has decreased. Total current in the battery increases. total current in the battery increases. Remember, small r is fixed and the current through the battery is increased, which means the lost volts due to internal resistance increases. Lost volts increases. Now let's look for the terminal PD, which is going to be V. So V is going to be equal to the EMF minus the lost volts. Now that the lost volts have increased, yet the EMF is constant, so it means V automatically decreases. V is the terminal PD, which is the PD across the two resistors since they're in parity is the same. So the terminal PD or the PD outside the battery decreases. So let's check. The PD outside the battery decreases. So C and D are out of question. C and D are out of question. Now what happens with the current I? Now note that the PD across the two resistors is the same. But the resistance R has not changed, it is fixed. And since the PD across it has decreased, because V across R decreases, from V equals to I times R, it means the current through R decreases. And because it is the same PD across the other one, whose resistance has gone down, so it means the current in RV increases because the PD should remain the same. So it means I increases, so the answer is going to be B. The PD across capital R has gone down as done before, but its resistance remained constant. So if the PD across it was, say, 20 and it is now 10, the resistance is 5. It is still 5. It means the current here has gone down. Let's say it is now, initially it was 4, now it is going to be 2 amperes when the PD across it goes down. The PD across R, because remember total current in the circuit has increased. The current here, if the current here was 2, and now let's say it was 3, and now it has moved to 6. So if 2 goes this side, it means more current is going to go this side, which means the current this side must increase. So it means the current through R decreases, the current through the variable resistor therefore should increase slightly, so the current I increases. A radioactive source produces a beam of alpha particles in a vacuum. The average current caused by the alpha particles in the beam is 1.5 exponent negative 9. The beam is incident on a metal target. What is the average number of alpha particles? So we want the number of alpha particles. I'll call it N. Hitting the target in a time of 3 seconds. So remember, current is equal to total charge over time. But the charge is going to be the number of charge carriers times the charge of each, the number of charged particles times the charge of each particle divided by T. An alpha particle is written as a helium nucleus He42, so the charge is 2e. So this is going to be N times 2e divided by T. So I want to find N. So N is going to be current times time divided by 2 times 1.6 times 10 to the power of minus 19. That is the charge of each charge carrier, E. So this is going to be 1.5 times 10 to the power of minus 9 times time, which is 3 seconds, divided by 2 times 1.6 times 10 to the power of minus 19. So I'll press the calculator. 1.5 exponent minus 9 times 3 divided by 2 times 1.6 exponent minus 19. So this is giving me 1.4 times 10 to the power of 10. So that means my answer is C. The charge carriers in a metal wire are free electrons. Remember, each electron has a charge of 1.6 times 10 to the power of negative 19 coulombs, and it's the magnitude and is negative. So the sign of electron charges is negative and the magnitude is that. Which statement about the charge of charge, which statement about the charge of each free electron is correct? The magnitude of the charge increases with a PD. For electron, the magnitude of the charge of an electron is the same. So this is wrong. The magnitude of the charge is 0 unless there is the magnitude of charge of an electron is still 1.6 times 10 to the power minus 19. The sign and the magnitude of the charge do not depend on the PD across the wire, so the answer is C. The charge of an electron has already been established to be 1.6 times 10 to the power minus 19 coulombs, and an electron is negatively charged, so it does not depend on the PD across the wire. The PD just determines the number of electrons passing a given point. In other words, it determines the rate at which the electrons flow, not their magnitude of charge, not the sign of the charge of the electron. So the sign of the charge depends on the PD, that is not Q. An electron has a constant charge of 1.6 times 10 to the power minus 19 coulombs, and the electron is considered to be negatively charged. Which flavor of quarks has half charge positive 2 over 3e? The teacher must have told you that any word which is related to something good corresponds to a charge which is positive 2 over 3e. For example, charm, top, and up. These ones have positive 2 over 3e. So let's say charm, correct. Top, correct. Bottom, no. That means number 38, our answer is going to be A. Charm has positive 2 over 3e. Strange has negative. This one is negative 1 over 3e. Bottom has negative 1 over 3e. So the answer is A. An unstable nucleus of an element decays by emitting an alpha particle. Remember, an alpha particle you can write as alpha 42. Or a beta particle, which you can write as beta 0, negative 1. That is beta minus. To become a nucleus of a different element. This nucleus is also unstable and emits an alpha particle or a beta particle. The process continues until an isotope of the original. If it is an isotope of the original, it means the final number of protons is the same. So let's start. Let the original nucleus be X, whose nuclear number is A, proton number is Z. So it is going to give us a certain number of alpha particles, let's say A alpha particles for 2, plus a certain number of beta particles, 0, negative 1, then plus a new nucleus Y, whose final proton number is still the same as that of X. So this can be another number P, we don't need P. So Z on the left hand side should be equal to alpha times 2, which is 2 times A. This is the number of alpha particles, A. I will change the color so that it is easy to understand. So we have A alpha particles and B beta particles. So it is 2 times A times 2, plus negative B, then plus Z. Of course, Z cancels on both sides, which means B should be equal to twice A. What does that mean? For every one alpha particle, there are 2 beta particles. For every one alpha particle, there are 2 beta particles. What is the minimum possible number of the particles emitted? So 2 is not correct, because for every one alpha particle, if A equals to 1, B equals to 2, which means total is 3. So the minimum is going to be 3. If A equals to 2, B will be equal to 4, which means the total is 6. So the minimum is 3. The minimum is 3. A nucleus of carbon-10 decays by beta emission to form a nucleus of boron. For this decay process, what is the change to a nucleon and what is the change in the quark composition? So we have carbon 10,6 decaying to give us a boron 10,5. Of course, we notice that we have lost a proton, and this is accompanied by beta emission. This is undergoing beta decay. So we have lost a proton here. So it means a proton must have changed to a neutron. A proton has been lost, so a proton has changed to a neutron. So remember, proton is up, up, down. So it has changed to up, down, down. So one up quark has changed to one down quark. So a proton has changed to a neutron, proton to a neutron, not a neutron to a proton. And one up quark has changed to a down quark. So the answer is going to be B. I think that marks the end of this paper. I've taken 5 more minutes because I explained more. Until next time, and I wish you all the best. Bye bye.